Thank you, Steve. Can everyone hear me okay? Are we all good? Lovely, thank you very much. Hi everyone, thank you for coming to hear me rant for an hour in front of you on your Thursday afternoon. My name's Neal. I work for a company called Proton. We're a privacy-first internet security company. We do private email, secure email, VPNs. I work on the VPN team. We've got stuff to rival Google Drive and password managers, things like that. The difference is that we don't sell your data, and we are expanding as well. So if you've ever fancied getting into the privacy and security space, do come and talk to me about some of the roles we've got open. So this is the Absolute Beginner's Guide to Mutation Testing, which is the title that the conference organisers suggested because they didn't like my original title, which was Mutant Codeopolypse, Release the Infection. They said it sounds far too much like ChatGPT wrote the abstract, and the reason is because ChatGPT did write the abstract. We kind of scaled it back a little bit, but we've got pictures of these mutants and zombies all the way through. I'm going to start off. Who writes automated tests at work as part of the process? Cool. Who writes the tests before the code? Some people? Okay, all right. Lovely, okay. So, right, automated testing. I love automated testing. I believe, I'm very passionate about high quality software, as I'm sure everybody in this room is because, that's why we do it, right? I believe that two fundamental pillars of high-quality software are good testing and good architecture. I think if you get those right, then everything else pretty much follows. The business doesn't always see it that way. They want, hey, look, features. And you don't always get the opportunity to build quality in sort of fundamentally as you'd want to. Does this ring true to anybody, by the way? Quick questions here. So these statements, I don't like testing, it slows my development. Does that ring true for anyone? Or what about, I focus on shipping features quickly because unreleased features don't bring value? Does that ring true for anybody? So when I asked this question before, like people that work in a very kind of top-down product environment go, yeah, that second one. Yeah, definitely. We focus on the features rather than the testing. My personal opinion is I don't like manual testing because that slows me down, and I like high quality features because unreliable features don't bring value to the business, to the customers. And the thing about when the company wants you to focus on features of the product, and I'm sure we've all been there where you work on something for a number of years, and products say, right, features, like we don't want to refactor, we don't want to spend time on tech debt, et cetera. You notice that the cadence of shipping stuff goes down and down and down, and it gets harder and harder and harder to develop any new features. So a key thing I think that you can go back to product people with, an argument you can go back to product people with is quality is a product feature. It is a thing that we build in. So what do I mean about this? So there isn't a product versus engineering mindset. We are all product people. We're all product owners. We all work on the same thing. We just have different areas of expertise. And you and the product team should be sort of discussing at the same level, what the features are and what the quality of those should be. And it's our duty as engineers to provide highly resilient systems to underpin the feature set. And we use our expertise to do that. And I think there's no features versus tech choice to make. So there's no kind of, should we work on a feature or should we work on improving the tech? I mean, obviously that does happen because we get into those positions. But a feature that doesn't work properly is worse than not having the feature at all. And we must ensure that the software always behaves in a predictable manner, and we achieve that through high-quality testing. If you sacrifice sort of the quality of the testing, I guarantee at some point you will have a conversation with the product manager where they ask why everything's always broken. And you will respond with something, well, it's because we focus on features all the time and we never get the chance to improve stuff. And the good thing is, quality is measurable. because business loves measuring things. They love being shown metrics and graphs and being, and say, well, if we do this, then that will happen. This is how we make decisions in business. And some metrics that the business care about, well, they can be divided into three things: value metrics, quality metrics, and operational metrics. Value metrics are for the customer, and these are ones. I knew this was going to stop clicking at some point. There we go. Okay, value metrics, things that the customer finds valuable. These are called pirate metrics, and I'll tell you the reason in just a moment if you can't guess it. But we've got acquisitions, activation, revenue, retention, referrals, and revenue, and these are things like, how many customers do we gain? How many customers stay with us? How many customers sign up? How many customers stay with us? How many customers tell other customers to join? And, how much money does the customer want to spend? At the end of the day, it's the money the customer parts with that puts the money in our pockets so we can go and buy toys and things to play with at home. Does anyone know why it's called pirate metrics by now? One or two, yeah? For the people that don't know, it's because it's A-R-R-R, so it's R like a pirate. Okay, so we've got quality metrics here. It's actually a bigger set than this, but the kind of core ones, I think, are availability and reliability. Availability is it there when the customer wants it, when they need to use it? And the other thing is, does it consistently do what they expect it to do? If they try to perform an action on your system and it works one day and it doesn't work the next, then that's not reliable. Okay, my argument is you cannot maintain a high-quality product without having high-quality testing. And there are things like that can expose us. These are operational metrics, things like how quickly do we get through tickets? Is the testing really bad that every time you try to make some sort of change in the system, something breaks and you have to manually debug and test it and figure out what's going on? These sorts of things, right? So there are, again, more operational metrics than this, but you've got things like, it's basically how long does it take for a ticket to go from picked up to done, and how long does it stay or go back and forth between you and QA, where they're going, you haven't done this, or like, oh, I've tested it in that kind of way, and these sorts of things. So delays in anything basically delay the amount of time that it takes for us to deliver any value. And remember, features aren't valuable until they're released to the customer, until they're being used. So how good are your tests? So the people that are writing, how confident, is anyone 100% confident in their tests that they could write some code, release it, and or do a big refactor, and nothing would break when it goes to the customer? Okay, I've got one or two people going, yeah, mine are that good. Okay, cool. 80%, 60%, 50%, we're kind of getting ready. I bet by this point as well, some people are thinking, you know what, but I've got QA for this. Right? I don't need my automated tests. I've got QA. And we'll get into that in a bit because you are wasting money if you're relying on QA for that. Okay, so let's name all of the metrics that we know for measuring our tests. Coverage. That's it, right? That's all we know. But coverage is it's a useless metric, really, and I'll tell you why. In fact, let's think about this. Like, you go hammer and tong to get 100% coverage on your tests. Okay? Maybe you'll go, our system's so broken, we need to increase coverage. We've only got 13% coverage, let's increase it, let's do it. And so you pull out all the stops, you tell the product people, it's going to fix all the bugs. There won't be any more bugs. We're going to hit 100% coverage, and bugs still go to production. Right. Now what? Where do you go? And this is why coverage is an awful metric to rely on alone. Because it's just a number, really. It's a measurement without any context behind it. And a measurement without context is just a number. It doesn't mean anything. It's like going, did anyone in Jacob's talk earlier where he just kept talking about 42 all the time? What is 42? No, it's how old I will be on my next birthday. So you don't know that yet. So you don't have the context in which I'm asking. What's 88? If it's 88 miles an hour, I can go back to the future. You know, this sort of thing, right? So numbers are just numbers, and it doesn't tell you anything. I'm going to show you why coverage is a bad metric. Coverage only tells you if a line of code was executed. It doesn't tell you if that line of code was actually tested or not, if it was evaluated. So here we've got, that variable a equals hello within that bar method. So in the test, we call the bar method. That line of code is executed and covered, but we've got some spurious kind of useless assertion at the end, right? We've got 100% coverage, but we've got a useless test. Now, obviously, this is a really stupid example. No one's going to write tests like this. But if you have complex tests, you probably do have stuff like that going on in your system. It only tells you that the line of code was executed. It doesn't tell you if that test was reliable. So this is a bit more of a kind of complex maybe more realistic case here. We've got something that says, the comparator, we're saying, oh, is this number bigger than 10? We're saying 9 isn't bigger than 10. Great. 11 is bigger than 10. We haven't tested the case of 10. So we actually don't know. We've got an undefined or unknown behavior around 10 because we haven't tested it. It also doesn't help you catch future mistakes. Bugs that you haven't even written yet. Okay, so let's say, for example, in this one, blah, blah, blah. So we go assert false. 10 isn't bigger than 10, great. 11 is bigger than 10, wonderful. But what we've done is change, like some developer, someone in my team that I don't know, don't trust, who's changed that greater than equals, less than equals to a double equals there. Tests still pass. Someone's written a bug in there and the tests still pass. That's why coverage is an awful metric. Coverage is not confidence in how good your tests are. But how do we measure confidence? That's the thing. How do we know? How do we get something in our face that says your tests are not doing the job you think they are? Infection. Well, it's actually mutation testing. Infection is the library for PHP. Which will sort of mutate your tests or your source code and run your tests. And I'm going to talk to you about exactly how it works. But there's a new hero in town called the MSI. And that is a metric that measures the quality of your test suite. And I'm going to go into what everything means here in just a moment, so you don't need to work out what all of these M's and dots and all the stuff is. The key thing here, I think, is just have a look. So we've got this thing, so the MSI here. This is the thing, the overall MSI is the thing to pay attention to, really. So let's look at how it works, and then we'll look at some results. So what's happening under the hood of it? When you install Infection and configure it, the first time you run it, this, by the way, I ran it on the Symfony HTTP kernel. And it was slow. It took 45 minutes to do the entire thing. It's the slowest I've ever seen a mutation run. I don't know why it was so slow, but it was slow. It might be because it was on this laptop and not a lot of resources available to it, but it did take some time. Okay, but the first time it runs, so each time you run it, the very first thing it does is it runs the unit test suite that you configure. And it needs to make sure that there aren't any failing tests because it needs to know if any changes it makes are what caused the test to fail. So you need to have your test in a passing state first before it will run. And we can configure which test suites we want to execute. We can configure which source directories we want it to look into and introspect and do all its funky magic with. Now, the way that it works, during that initial test run as well, it collected coverage information. So we've got a few examples here. So say, for example, we've got a method, we've got a few test methods here, like test add, test subtract, blah, 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 and so it maps to the lines of code. So these are lines of code at the top, so short closures. So it runs the tests, maps which lines of code each of those tests executed. And that prevents it needing to run all of the tests for every single mutation that it makes. But it kind of goes, well, you know what, if I take, I don't know, maybe that fourth column there, so this column here, if I change some code in there, I know that I need to run test square and test big int math. Okay, it doesn't need to run the other tests on it, against it, to know that if that should, either of those should break. Okay, so first of all, it maps that. The second thing, well, let's have a look what happens even deeper under the hood in PHP with a function like this. Is anyone familiar with the abstract syntax tree, which is a difficult thing to say? All right, so we've got a function here, or a little class here with a simple mesh. It's the same one we looked at earlier, and the test underneath. So we've got this thing called a function is bigger than 10, and it takes an argument, and then it's got a condition in it that says if this is less than or equal to that, then return false, otherwise return 2. Under the hood, as part of PHP's execution, it builds this thing called the abstract syntax tree, which, come on, there we go, looks like this, basically. So we've got the test code, and that invokes in the source code this thing, which is basically, it's a text representation rather than a diagram, but I know everyone here is going to want diagrams because they're prettier to look at and you can use colors. But the AST basically looks like, well, condition, and then we've got this thing going on here, which is the candidate and the check in the middle, and then underneath we've got this return false or return true if things like that are happening. And that's what PHP builds from your source code. And what infection does, or what mutation testing does, is looks at that and then figures out what changes it can make, how it can break your source code to do that. And it makes those decisions based upon predefined rule sets. So there are things like, we'll show you how some of the mutations are generated. The mutations that it makes, or each time it makes a mutation, it calls that a mutant and it runs a test against it. But for each of those, it does them one by one. So it doesn't do 2, 3, 4 mutations at once and then test. It goes, you know what, I'm going to make the first mutation, run the test. Do the second mutation, run the test, blah, blah, blah. So let's look at some of the mutations it will do. Right, remove the if condition. Run all the tests that should cover those lines. Do any of them break? So that's the first mutant. Second mutation would be, well, put the if condition back in, but now it's switched that less than and equals to a greater than and equals. Run the tests which should break when that mutation is made, which should cover, which should be covered by that by those tests. And then less than and equals becomes a loose equality. And then we get rid of the equality and just change it to a less than. And then it does incrementers as well, so it increments the variable passed into the if condition. And then decrements as well. So it does all these kind of little things just to try to blow up your tests. Returns the, switches the return statement from the if condition. So instead of returning true, we're returning false. And in fact, we're returning true both times there. And then the other way around as well. So, so it's switching the return statement for the false condition. So we get false both times. So it would map every mutant to each test which should cover it. So this is just a kind of example that I threw together. It's not actually representative of those examples that I showed beforehand with the math tests or anything like that. But once it's mapped all of this, it then runs those tests. And this is the key thing now. This is the important part of it all, is any tests which fail, where we have apology. Is anyone colorblind? Because I didn't think about that. We've got red and green up here. Any tests which fail, the mutant got killed. So those tests are reliable. If any mutants get all the way through, no tests fail, that escaped. And this one escaped as well. So we've got 2 mutants escaped from here because none of the tests failed. We've got one here as well, which calls an error. Now, errors are not as good as killing mutants, but they're not as bad as escaping. Because if the mutant escapes, you don't know if you've persisted something into your database with an invalid state. You don't know what's happening in your system. You don't know if there's a possibility you may have transferred money to somebody you weren't meant to. You might have overcharged your customers sort of 6 months early or something like that. You honestly don't know. You've got undefined behavior. At least with an error, something went wrong. So that's kind of not a brilliant journey for the user if it happens in prod, but it does at least mean that you didn't do anything bad. So let's look at what mutation testing and infection specifically can tell us. So we've got here a whole bunch of things. We've got lots of, they're M's for mutants that escape, but I always look at it and think, that's the Gmail symbol. I've got loads of emails. Okay, so U's, we haven't got any U's in this actually. U's are uncovered. You just don't have any tests for those particular lines of code. They're always very quick to come up at the beginning because that gets exposed during that very, very first mapping call that it makes, so mapping run that it makes at the beginning. M's are the escape mutants, which is bad. There's something in the system. There could be lines of change which are lines of code which are changed, and we don't know. We don't know about it. E is a runtime error. We don't have any E's here. Not great, but at least the system failed in some sort of way. And T's, again, we don't have any there. But again, those are timeouts. Again, not great, but it's better than the system silently going, yeah, everything's fine. Okay, so understanding that output. So we had that score. What was the score? I forgot what it was. MSI score was 70% there, which I kind of take to be, it's great, we got it here as well, 70%. I kind of take that to mean 30% of the code could be changed and we wouldn't know about it. That's kind of a kind of rough thing that rule of thumb that I use. Okay, so MSI, mutation score indicator. Remember, that's the really top one. In fact, these are slightly different values because it was 70% the last one. I've put 10% there. Okay, but this is the number of defeated mutants over the number of total mutants that were released and then times by 100. Mutation code coverage is, obviously code coverage we know about, and this is the number of covered mutants over the number of total mutants, and then the covered code MSI basically is a subset of the overall MSI. You could have a really good covered code MSI, but only have covered about 5% of your entire code base. So that's why the top line one, so the global MSI, is the thing to look at. So how do we address the issues? We've got a whole load of output here, like loads of uncovereds. There's an error here. There's an E there. I don't know if anyone can see it. And then loads of M's. Oh, by the way, for the Symfony HTTP kernel, look, so there's 1,424, I don't know if you top left at in red, 1424 tests, but it generated over 5,000 mutants for those. There's a lot of code in there, but it generated so many mutants. So yeah, I guess 5 times as many mutants as tests. So there's a lot of potential code paths to go wrong. There's a lot that's not covered there, but this is only showing us, again, this is just a measurement without any context around it, isn't it? How do you know where to look? Well, what you can do is run it with show mutations on the command line. So as a command line argument, and this then tells you what it did and the exact mutation it made and what rule set it is as well. So we've got on very top here, so it says M in square brackets at the top, it says false value. So it has changed a false into a true. It even gives you the diff of what it did. Look at that. So you can go in there and say, I haven't tested the case for must revalidate being false or true. I haven't got tests that cover both of those code paths. This one here, Method call removal. It removed a method call, the constructor to the parent. And nothing broke. So is that an important constructor call to the parent? Or can we just remove it from the code? Code still works, right? There's some things as well. I mean, one of the things that you can do, well, maybe we'll find it in a sec. But it'll tell you, the file, the line, and the mutation that it made. You can also configure it to go to a logger as well if you want to do that, rather than scrolling through the shell output. A lot of mutants can be killed, and we might see this in a sec, just by adding stronger typing. You know, instead of using strings for email address, use an email address object and put some validation on it. So many mutants can be killed like that. Or by throwing exceptions. Like there's a lot of stuff that you can do. Where are we? Sorry, I just hit that there. Cool. Next one. What do we have here? Okay. So mutation here was, it incremented an integer. I told you it was going to do that, didn't I? And, okay, so it's incremented an integer here, blah, blah, blah. Nothing broke. It did something with a concatenation. Oh, it changed the order of this concatenation, look. That seems, the argument resolver. Look, so it's got the controller class name in the method, and it's absolutely mashed that, and nothing broke, no test broke. Isn't that strange? Okay, what do we have here? So instance of, a test for instance of here, so it just went, you know what, else if true. Yeah, whatever, have that. And then the very top one, coalescing something or other. Oh, you know, that looks horrible there, doesn't it? What was it done? What was it done? So, coalesce to null, blah, blah, blah. Is it the first argument and the second one? Oh, yeah. Yes, yeah, well done. Yeah, lovely, cool. Are these lines of code important? Someone wrote them, they must be important. Like every line of a code is correct and important when it was written. So why isn't it tested? Okay, so mutation testing is really great because it puts it in your face, the stuff that you've missed. All right? And some issues are maybe not really that costly, right? And you do get false positives, but there are more insidious cases, like, you know, if a function called to save, like your latest transaction, was removed, or if something happened which cost your customer or your business money. You know, these are more, much more kind of serious issues. So how then do you bring mutation testing into your workflow? You might think, well, you know what, I'll do on absolutely everything, every PR as part of the CI pipeline, and we have to fix all the issues, blah, 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 get the MSI up to 100%. You might think, you know what, unleash the mutant swarm, right? Let's just do everything. And there's some cases where it can be good to run it on your CI pipeline all the time and reject if the MSI drops. I know I've known of engineering managers that do that. They've come into a code base and gone, right, first thing we're doing is putting mutation testing in, and it must always pass now. Those tests are usually in a pretty good place anyway, and they're not tests that take forever to run, and you know they're usually kind of well encapsulated modules, and you know where you're not sort of hitting the database for absolutely every single thing. If you've got a slow test suite and everything's like up, like if you've got the everyone knows the testing pyramid, right? The wider at the base. If you've got the ice cream and the big old turd on the top because you made a mess, like that's probably not a good place to be running mutation testing all the time, because it is slow by its nature. And if you've already got really slow tests, it's just going to make it even worse. 45 minutes for the Symphony kernel, like I say. Okay. You're going to wait a year for infection to complete, and you're not going to run it, are you? Or you're going to loathe running it if it takes too long. So killing mutants before they swarm is before they spawn, is a really good tactic, I think. And what do I mean by that? In my experience, there are two main approaches, and I talked about them earlier on, which, when you combine them, lead to a lower initial MSI, and as long as there's time there, it should be time, yeah. I'll demonstrate that to you as well. If you do black box style TDD, so who was in Jakob's talk earlier? Everyone, he kept talking about TDD, didn't he? And well, he said, I'm not going to talk about TDD, and then started talking about TDD. TDD, if you use so black box, like BDD style TDD, so many acronyms there, which I've probably confused people with. The best thing I can say on TDD is read Kent Beck's original book. It is such a simple. If you've never done TDD and you've never thought about it, or you're kind of like unsure about how to start, read the book TDD by example. It's such a great introduction to it, and it's so simple to follow. And so that is one thing, right? Do not write any code which doesn't satisfy a test that already exists, and test constantly. Just PHP Storm, everyone uses PHP Storm these days, I'm sure. You can set it to automatically run your tests every time you make a change. And that's what I do. I have it set to run every time I make a change, and then you just get a little bit of green, oh, a little bit of red, oh, I broke something. Great. And then the other thing, which I think leads to initial MSI being higher, is using a modular architecture, something like hexagonal or clean architecture, and so having highly decoupled components and testing at the behavioral boundaries and making sure you test behavior rather than implementation. Again, that's covered in Kent Beck's book. These are the things which will lead to higher quality test suites. Build your modules out from business logic well before you think about the database storage or the input and the outputs and these sorts of things. This is the best way of testing, I think. And get code out of controllers, get it into services. You shouldn't have logic in controllers. Controllers should probably just be there to take the HTTP request and transform it into something that a service can understand. And your tests will just improve in quality doing that. So we can catch these issues higher up, right? This is what we pay QA for. At least one person in this room is thinking that. Getting QA to do your work for you that you should be catching right at the lower levels, it's slower, it's more expensive. You're probably not going to catch everything all the time. Certainly not going to catch all the things that a mutation framework can catch for you. QA is going to do some input clutter, going to put in -1 for a date of birth rather than my year back in the last century. But they're not going to catch absolutely everything. They're not automated. They are slower than mutation testing. If you don't catch those edge cases in your integration or your end-to-end tests, then yeah, you are definitely asking for the QA to do it for you. And you are wasting so much time and money. Because you could be working on the next, you could, whilst you're doing the back and forth between QA, and they say, well, you know what, like this doesn't work when I put that input in, and you go, hell are you putting that input in for? That sort of thing, right? That kind of back and forth, right? This is good enough, no, it's not, blah, 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 blah. You're wasting so much of your own effort and time on stuff that doesn't really matter and that could be solved for you. And you are making your life more stressful and theirs. Okay, so how do we win the war? What's the strategic plan for defeating that mutant horde? I've got some tips here. So first of all, understand your enemy. Keep an eye on that MSI. One of the things that we did at my previous job was we just ran, because it was a slow test suite, and we just ran infection twice a week and got it to spit out the results, and we just tried to keep an eye on it and figure out what the lowest hanging fruit was going to be every time to fix. I wish we'd been a bit more what's the word I'm trying to say? A little bit more engaged with it or more kind of ferociously trying to fix the MSI, because we saw the graph go up a little bit over time, like the scores go up a little bit over time, but I think we could have done a lot more. But keep an eye on the MSI. Understand about what it indicates about the quality of your test suite and the level of protection they're giving you, because this is the product that you are responsible for as well as the product people. and make your interactions with them a little bit nicer. Pick off easy targets. Use that logger that we showed you. Like you can either sort of have it output to the console or into a file. Add new text. Well, identify simple cases first. Things that you can knock out just with some strong typing or with some exceptions. Add new tests for cases that you can't fix with typing. Because you can just identify things. I think there was like that one with that coalescence or the string concatenation. It would be so simple just to write a new test for that. Don't try to modify old tests. Just write a new test. Cover your fastest test suites first. So if you've got a whole bunch of tests that could be unit tested with very simple stubbed dependencies, but you're doing it all through the container and stuff, like try to decouple that from the container, get those running really quickly, make sure you're covering the behavior, and refine your architecture, extract cohesive modules as they become apparent. Because this will help you clean your architecture up as well in your system, especially if your system's difficult to work with. Like I said, function-oriented black box TDD approach with a modular architecture, highly decoupled. It gives you a strategic advantage from the outset. Keep the enemy out and trust nobody. You know when you watch like horror films and somebody always just leaves a little back door open? Yeah, you go, you idiot, what did you do that for? Oh man, you're all going to die now, the zombies they got in, or the vampires at the window and things like that. Okay, don't rely on other people, especially if you're working in a team where there's, or in different teams where there's a lot of sharing of code going on. Don't rely on other people to send you data that's correct, or to give you objects that work correctly. Always make sure that you protect yourself. It's in a domain-driven design world, we call that the anti-corruption layer. Make sure you protect yourself from the shit that other people are going to give you, because you want to make sure that your system behaves as you expect it to. You want to make sure you filter out anything that anyone is going to try to attack you with. And there are no heroes coming to save you. You need to save yourself. Don't rely on QA to do your job. Because you need to have your own personal discipline to write better tests. The thing about mutation testing is it will show you where to begin. Okay, with that, so I've got a couple of examples that we've got a bit of time for. First of all, are there any questions? By the way, all these images were AI generated as well because I'm rubbish at art. And I thought these are great images, and I couldn't decide which of them to pick, so I just put all of them in the end for the mutant horde and the questions they may have. So, are there any questions to begin with? We've got one on the back.
This might be a bit far-fetched, and also probably because I don't really understand the actual concept of it. Not the mutation testing.
I have failed.
Speed. Is it potentially like for infection, like using PHP fibers or something, or is that like does that actually sort of break the whole? If we can get some concurrency testing in, like in things like PHP unit and pest, you can do parallel testing. Or do you really want to do the mutations in order? Would it just like make no sense to jumble them all up?
You know what? Okay, so good question, and that's like a level of question beyond what I was expecting. So thank you. No, that is a good question. Okay, so two things I think. Firstly, so infection runs the tests with the random flag for PHP unit to begin with. So it doesn't rely on a particular order. It just goes, you know what? I'm going to run these randomly, because I want to smoke out any issues anyway. I don't want to. I'm pretty certain, you know what, I'm going to come to, I think you can run it. Usage, blah, 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 blah. I'm pretty certain that you can run it with a number of processes. Yeah, see, there's a threads, which, where are you? There we go, right. Look. I hope there's no work-sensitive stuff on here. But there's threads option here. I'll make that bigger. There you go. Can you say it, Jim? Lovely. Yeah, so there's a threads option there. So you can run them in parallel, actually, which will dramatically speed things up. Oh, so ignore what I was saying about speed because you can speed it up. No worries. Right. Okay. Any other? Yeah, we've got one or two around. Lovely.
Oh, cheers. Firstly, I really enjoyed that.
Thank you.
Secondly, just because when we were looking at legacy code bases we've been working on, they used to run infection, but they stopped because of speed. But that was quite a few years ago before we were looking at it. In recent time, when we've been looking at it, I think it was even on the screen then, in the CI you can do the git diff, which runs which obviously won't help retroactively, but going forward it's a really useful way of just tracking things going out in the future.
Yeah, this one. Yeah, thank you so much for mentioning that. Yeah. So you can configure it, as I said earlier, you can configure where you want it to run, so which source directories you want it to run on. I can probably show you actually an infection configuration file in a sec. But yeah, so yeah, you can set it to only run on stuff that changed in the last diff on your CI pipelines as well.
Yeah, thanks for the great talk. I've got a question. When you want to start with infection on a new project, would you say that starting with PHP standard or something first makes this easier or faster to have static code analysis first to kind of weed out all of those issues before you then start with mutations?
That's a good question. Does PHP... I don't see that it... You know what? Okay. The code bases where I've seen the lowest MSIs have had like high PHP stan settings. It just means the tests were crap. So in terms of type safety and trying to smoke out issues like with compilation and things like that, that a compiler in another language would give you, for sure, yeah, that's going to help. But that's it still doesn't mean that all your behaviors are tested. But no, I think you're right. So infection will help you catch, or mutation testing will help you catch those classes of issues as well as PHP said. So there's an intersection of in the big Venn diagram of crappy code. So I think they would go hand in hand. I don't know if one over the other would. I don't think PHP stan or SARM would ease using infection. I think, to be honest, it's going to find it anyway. Thank you.
You mentioned halfway through your talk that you set up your PHP storm to run your tests every time you change a file.
Yes.
Can you please elaborate a little bit on that? So at first, what do you mean by file change, and how fast is your test suite?
Yeah, okay. All right, I don't think, because this is my work code and I can't broadcast my work code around, but there's an automated test runner in PHP Storm, and it's every time you save a file, it's just going to go bang, and it runs the test and gives you the output in the IDE in front of you, and if any tests fail, it gives you a link to the exact piece of code where the test is. It doesn't have to run all of the tests. You can select to run one test over and over and over again. You can select to run a file. You can select a directory of tests, whatever, right? You can scope it to whatever piece you're working on at the moment. So if you've got a modular architecture, you can go run all the tests for this little feature, this little bundle or package that I've got right now that I'm working on here. And then when you're done with that, you can just run everything, I guess. Does that sort of answer your question? I feel like maybe there's something different you wanted me to touch on.
No, not really, because in my opinion, a test suite always takes a long time to run because we already got a bunch of tests. So,
all your tests in one big directory. Okay, yeah. If you organize is it feasible that you could organize your tests by the feature or the behavior that they cover?
They are a bit organized by the feature, but not all, I think.
Okay. So if I was writing, let's say, for example, I was working on a system that had a shopping cart in it, like maybe Amazon or something, and I was doing working on adding products to a shopping cart, I would probably just have a little folder in my tests called shopping cart. And I would put all the tests related to the shopping cart in there. And then I know that if any tests within that directory break, my shopping cart feature is broken. But it also means that I can work on that in isolation from the, like the product properties feature or something like that. So I think it sounds a bit like an issue that you may have is maybe tests are kind of so not necessarily isolated enough to be able to be run independently within that. But I guess it's a case of like, just have a look at your code, and because no one knows it better than you do, have a look at it, right, and see what you can do to reduce the scope of how big those test runs are. We got one down. There was a hand went up a few times over there, but I don't know if it's going to come back up. We've got one on the front here.
Yes, hello. Great talk. So it's just about the mutations. So some of those mutations that you showed the one about turning true to false.
Yep.
How easy is it to write your own mutations, for instance? Are these all standard mutations somewhere? Can they be extended?
That I don't know. I mean, someone's written them. I mean, the list of mutators is here. There are a lot of things that it can do. I honestly don't know. I imagine you probably can. You can, no, this is PHP extension. I know. You think, yes, how to extend, right? But this is PHP extensions. I honestly don't know. We'll have to have a look in GitHub, I guess, and figure that out. Yeah. But I think, to be honest, I mean, most of, I don't know, well, again, it's your code. You know it better than anybody else.
It might be good to be able to write your own mutations, just to say, I want to do this.
Yeah. But I think there's probably a high chance that a lot of stuff is probably covered by the default ones by the default set. But that's a good question. I don't know. Yeah, hey.
Yeah, just to follow up on what was said before, in PHP unit you can actually say this test belongs to a certain group. Mm-hmm. And then, for example, if it's got something to do with the shopping cart, and then you can just run the group shopping cart, and then it will only run those tests. So that's another way to group them together, basically.
Correct, yes, yeah. So you can say, you can organize your tests into suites, and you can get infection just say, I only want to run this suite. Are there any more hands? Because otherwise I can show you a couple of demos really quickly. We've got a little bit of time. Yeah, we've got 10 minutes. That's cool. Right, okay, right, let's bring this up here. Everyone can see that, right? Let me clear this. Okay, so this one should be, which is this? Okay, so this is the code test that when I applied for my job. So I've got two examples of the same thing here. These are the code tests that you do. We all do code tests. Like when I joined my job, I took a TDD approach and with a modular architecture, and then I put mutation testing on once I was happy with with my solution, and then used infection to show me anything that I'd missed. And I can show you the vendor bin. So this is, I've actually, what I've done as well is checked out an earlier version in the history, which was before I had fixed all the things. Infection, here we go. So this was the state of it just after I added infection. So we can run it, so you can see it's running that initial test suite. So there we go. So I've got a few things, about 12, I guess, uncovered things here. Everything else is okay. So 23 source code files. I'm not going to show you what the task is, by the way, just in case anyone wants to join. I'm not going to give you a kind of a preview into what you have to do. Let's still make that bigger. Let's make it really big. So the test suite itself, part of your question was how fast are the tests? So my test suite is usually, I'm upset if a test suite doesn't complete within about half a second. For unit tests, like for integration and end-to-end tests, obviously, that takes longer. That takes if it's more than 5 minutes, I'm upset. For an entire system, but usually I want each of my modular unit tests to be within about half a second. Okay, right, we're nearly there. Okay, so this was on the thing, yeah. Like I say, I did infection on, and then, oh, are we going to get a timeout? Oh, we got a timeout there. Okay, great. Well, but this pointed to me things I could fix. And what I did was I fixed them, and then I sent my code test in once it was all fixed. I was like, you know what, this is bulletproof. This is where I am. So that's one where I took a TDD approach. So overall MSI, 86. It's not perfect, but covered code MSI. So my biggest problem was some uncovered code and then a few mutants as well. That's not a bad score. A colleague very, very, very kindly lent me, here's one. Let's clear that. He gave me his one, and he said, well, you know what? You can see the results at the top anyway. I've already spoiled it, but, you know. Docker, I can't spell when people are watching. There we go. Right, okay. So he gave me his one, a colleague gave me his one, and I haven't, I didn't even mention his name when I demoed this at work. But he said, you know what, I wrote my tests after the implementation, and I said, please, can I use this to demo the difference between, what? Oh, I didn't go in there. Bin, SH, that one. Oh, no, I don't want to do that, no. Oh, no, I just run it. Cool. I thought I'd remove it. You know what, it's going to be, oh, no, I'm in there, it's cool. Where am I? Yeah, CD. I'm. Oh man. Okay, yeah. Whatever. Come on. How do I quit? It's like trying to get out of Vim, isn't it? You know what? I could have just done that one. That was the one I was after. I should have just pressed up 30 times, shouldn't I? Okay, so. CD, var, and then it was in www, I think, and then if that's here, it should be here, yeah, cool. So I can do vendor bin infection, so I installed it into his one. There we go, okay, so it's running that test suite again. Oh, look at all that uncovered stuff. Oh, and a fatal error. Okay, fatal error is okay, couple of M's. It's actually got about, I think I had about 130 mutants in total. He's got 111. Look at that. So covered code MSI isn't bad. The stuff that he's covered, he's actually covered it well. In total, though, look, 36%. Yeah, and this was because he said, you know what, I wrote the solution and I added the tests afterwards, and that was that. Let's exit that. I guess if I come back to my one, we've got a couple of minutes, yeah. So let's then infect. Where am I? CD app. I don't know what I'm looking at now. I can look down here and get the same thing, right? So if cool. Vim infection. There we are. So this is like the kind of a very, very, very slender config for infection. And see that on line kind of 3, 4, here we go. If I put in visual mode here. So I'm telling it what source directories I want it to mutate. I'm telling it where my code is that I care about. It won't cover then like the vendor directory or anything like framework related, things like that. It's like this in the source directory is where my stuff is. This is what I care about. And we've also got so PHP unit config stuff here, and then, and then for some reason I created a group called Mutation Ignore. Maybe there was one test that it just didn't make sense to, I think I had a test that was trying to do some randomness and some time-based stuff, and it was just too tricky getting mutation to go onto it. I guess kind of the overall goal would be to sort of tag that into a group, and then fix those one by one. Oh yeah, okay, yeah, that was it. I was doing this whole kind of caching thing because I was massively over-engineering it and having a load of fun putting a triple caching strategy in with Bloom filters and and like SPL storage and things like that, which I got rid of by the time I submitted the thing. But I was excluding those parts of it. Yeah, so that's that. But it's a fairly kind of a simple setup, configuration, and that's about it. Like I don't know what else there is to show. So thank you very much for coming and listening to me. I really appreciate it, and I hope you have a lovely day. Thank you.